Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So today I would like to present my research progress report for semester 2, 2021 and 22. So my title is Optimal Load Management System of Plug-in Electric Vehicle (PEV) using Time of Use (TOU) tariff for residential networks in Malaysia. So this is my research team, okay, which is my supervisor is Professor Madia IR Dr. Novi Yanita, and my co-supervisor is Dr. Muhammad Fani. So this is my research milestone so far is up to semester 2. The problem statement is 100% 100% finish, done, and same for objective. 60% of the scope of study has been covered. Same to literature review, and for research methodology is 20%, which is I only covered the objective one. 10% for data collection and 10% for data analysis. So this is the research milestone so far for semester 2, after semester 2. And this is my Gantt chart, okay, from the beginning of my study on September 2021 until August 2024. Okay. Okay, why I choose this topic? So why? Because number one is because of the increasing of the PEV on the road. So uh, there are concern on this issue. Number two is because of the latest budget, government implement the tax exemption in the duty import, in the import duty, excise tax and sales tax on EV purchases starting in 2022. And number three is also because of the increasing number of public charging station, okay, EV public charging station, which is up to today. We have in Malaysia 336 station, public EV station, and of course because of the increase of PEV, also will increase the number of home charging, okay, because if you buy EV, you will get the wall box charger come with your EV, okay. For example, Nissan Leaf EV, which is it come with the wall box charger type 1 that you can install at home, okay. So this is why I choose this topic, okay. So I divide my problem statement into three parts. The first one is on the cost issue. Okay, increasing number of PEV on the road leads to more EV charging either in public charging station or home charging. Okay, so current situation, public charging station, okay, public charging station. The EV user can choose they have free charging station, or they have to pay, okay. So there are a few public charging station developer in Malaysia. One of them is Charge EV, okay. How about for home charging? Home charging, so far there is no specific meter, there is no specific tariff for the EV charging load, okay, which is when we charge at home, for type 1, usually it takes about 7 hours, so high load consumption will be half for the home. So we still use domestic tariff, okay, or I refer to the EV user lah, okay. And Problem statement number two is on the technical issue, okay, which is increase in PEV charging activities, congested distribution system. Okay. Uh, okay. So there is this slide is referring to the slide for the literature review on the EV charging effect on the distribution system. Okay, later we'll see. And then for unplanned EV charging system, okay, unplanned, which is with the existing distribution system, let's say with the existing of transformer at our home area, okay, it will increase the peak load. Okay, the increase the transformer loading, okay, transformer aging will be faster voltage profile effect, and also affect the protection of the electrical system if we don't have the unplanned EV charging system. Okay, so that is on the technical issue. Probable statement number three is on the benefits. Okay, benefits, uh, which is combined which is these benefits will reflect to the user and the utility company, which is in Malaysia we have on Semenanjung we have TNB lah. Okay, so we want to have a new tariff that suit for home EV charging, which is the house load, normal house normal house load, sorry, for EV charging. Okay, and the dynamic price for the normal house load means that we want the new tariff that's suitable for these two kind of load, for house load and also the EV charging. And then we want to have the load management strategy that um, which is I will combine three: demand side management, price based program, and optimization technique to have this benefit for user, okay, for them to pay the suitable charging cost, which is the lowest. And for the utility company, we want that uh, they can control the load or energy demand from the charging activities, and also can manage the operation cost, means that they still have they still can manage the operation cost even though the user pay the lowest price of charging costs. Okay, that's a three publics. That there is a three problem statement. Okay, from the problem statement, I come up with the three objectives. Okay, objective number one is to formulate an optimum simultaneous load management strategy to minimize PEV charging load demand and costs using different time of use tariff electricity pricing structure. Okay, so number one, I will see the load management strategy, okay, to minimize the PV charging load demand and the cost on TOU. Objective number two, to enhance the optimization of load management strategies in objective one by integrating the DSM technique using hybrid fuzzy logic, PSO, and GA optimization algorithm. So this one is the combination, okay, the hybrid using the DSM and also TOU electricity pricing structure. Okay, objective number three is to determine the effect of applying optimal TOU electricity pricing structure into on PEV charging load and residential load in maximizing consumer and utility company benefits. So this one reflect to the problem statement number three. So I have three objectives for my research. Okay, next is the scope of research. So for scope, I have four different parts, which is number one is the PEV vehicle and charging specification. This one is focus on the EV itself. So the car that I use is Nissan Leaf. Uh, and then why Nissan Leaf? Because Nissan Leaf is currently the Number one, purchase EV car in Malaysia because of the price is the lowest. Okay, and the battery capacity for this car is 40 kilowatt hour. Okay, charging capacity is 6.6 kilowatt and 7 hours full charge. This one is home charging. Okay, and then the price based program. This one is uh, the TOU tariff. Okay, with price elasticity and domestic tariff (DNB). I will apply these two to my analysis. And demand side management system, I will choose two types: the valley filling and load shifting or combination. Optimization technique, have three. Optimize fuzzy rules control is to estimate the state of charge of the PEV. Okay, PSO is for the PEV charging load management. GA, genetic algorithm, is for the TOU tariff scheme adjustment for PEV charging load profile. Okay, so I also will do the analysis and experiment simulation considering the state of charge of the PEV. This one is we're going to the literature review. So this one is the literature review on the EVE charging effect. Okay, so this one is important. Why I want to do this research? Okay, so for EV charging effect, there are a few effect that there are a few type of effects that can harm the existing distribution network if we don't control the EV charging activities. So the effects are the load peak or load demand, the effect on the THD, total harmonic distortion, the effect on electrical protection system, okay, transformer aging, transformer loading, voltage quality, and the one of the research is doing the research on the EV charging behavior. So these are the references and the year. So the references is from 2018 and onwards. Okay. So for all these references, okay, most of them use mathematical formulation. Okay, either they use a manual or MATLAB software, and some use modeling using the silent software. Okay, so this one is brief literature review. This one reflect to the problem statement and objective that for my research. Okay, so there are three categories also: EV charging under price program. Okay, so this one I want to see the time of use. Okay, TOU, real time price, RTP, and plate rate tariff. Okay, so focus on the residential network and the and most of the research is to study the effect of EV charging using price-based program. So these three. Okay, so the second one is the optimization for EV charging. Okay, so this literature review focus on the optimization technique using some algorithm. Okay, done by other researchers. Okay, so it includes other than residential, which is there are various type of network, and then most of them is also study the effect of EV using optimization technique. Okay, so the researcher want to see if they use this kind of optimization technique, what happened to the EV charging activities. Okay. Number three is the combination of the price-based program and optimization for EV charging. So this one is the combination using the any uh, price-based program and EV charging. But for my research, I will focus on the TOU, okay, time of use. So this one also the researcher want to study about the effect of this combination to the EV charging effect. Okay, and also include the various type of network. Network means that uh, the experiment, the simulation, okay, is done on distribution network, okay, low voltage distribution network, including residential, commercial, industry, uh, or charging station. Okay, alright. So this one is the list. Okay, list for review EV charging under price-based program. Okay, these are the lists. Okay, so I just skip this one. Okay, just the list. All right. For research methodology. Okay, so from the research milestone for research methodology, I only covered uh, for objective number one only. Okay, so these are the methodology that I will cover. Okay, so this one for PEV and charging specification, this one is the specification of the car. Okay, so the important things in this is the battery capacity and the charging capacity, 6.6 kilowatt and the 7 hours full charge. Okay, and residential load profile. So I use single story bungalow. I have two type of load profile, which is weekday and weekend load profile. Okay, and TOU price segmentation. So I have four blocks of price segmentation of TOU S1, S2, S3, and S4, which each of the block have two value of price elasticity, the same value. Okay, so later we will see what is the price elasticity. And PEV charging scenarios, I have five, three for weekdays and two for weekends based on the Malaysian driving behavior. Okay. And lastly, the optimization technique that I will use later is optimize fuzzy rules, DSO, and GA. Okay, so this one is the residential load profile. Okay, for the weekday and weekend. So this one is the real data coming from the smart meter TNB. Okay, PEV charging scenarios. So I have five. One is for weekday is I have TC1, TC2, and TC3. So TC1 is charging from 6 to 1 a.m. 6 p.m. to 1 a.m., which is all this is 7 hours charging home charging. So why TC1? Working people start charging right away after reach house. So let's say they reach house at 6, they right away charge their car, okay, for 7 hours. TC2 is working people start charging before sleep, okay. So they start charging their EV at 10 p.m. until 5 a.m. Okay. And TC3 is stay at home people, which is this one is not working. So charging time maybe they choose 9 a.m. to 4 p.m. Okay, all these 7 hours. And for weekend, I have TC4. So this one is categorized as frequent travelers or long distance travel, which is they start charge at 11 p.m. to 6 a.m. And TC5 is stay at home people. Charging time is 10 a.m. to 5 p.m. on weekend. Okay, so this all based on the driving behavior. Okay. Okay. So this one is for objective one, the optimization formulation used to determine the optimum TOU prices, which this formula is coming from the main reference uh, my of the journal, one of the journal. Okay, so this formula is used to come out to this use for this schedule. Okay, So this is the TOU price segmentation that I will be used for my research. So there is four blocks: S1, S2, S3, and S4. Which is S1, they have four blocks. Okay, for 24 hours, they divide the 24 hours into four blocks. S2 divide 24 hours into six blocks, and S3 divide 24 hours into 8 blocks, and S4 divide 24 hours to 12 blocks. Okay, blocks means the price segmentation. Okay, from this, table, there is another one table which is more details with the price for each hour. Okay, so this one is the TOU price segmentation with the price, okay, for each hour. So um, in this research, I will use two values of elasticity, okay, which is E is equal to minus 0.02 and E is equal to minus 0.27. Okay, so this value represent different group of user. Okay, one group is that respond highly to price changes, okay, which is the negative 0.02. Another one is the group that does not respond. Okay, so this one is coming from the reference number 53 and 54. Okay, mm, so for the fixed price, okay, fixed price is important. Okay, it's assumed to be 25 cents. So this one also coming from the same reference 53 and 54. Okay, so these are the price segmentation. So S1 is 4 blocks, S2 is 6 block, S3 is 8 block, and S4 is uh, 12 blocks. Okay, so let's see the result for objective 1. Objective 1 contain 3 objective. So I want to see the effect of the PEV charging to load demand. This one is theory. I just use the Excel. So PEV charging under TOU price-based program, daily, I want to see the daily electricity price and monthly electricity price. And lastly, the PEV charging effect to the energy consumption. Basically, we want to see first the load demand effect. Okay, when you charge the EV, and second one, we want to see which price segmentation is suitable for the EV charging and for the house load. Okay, so for result number 1, okay, so this one is, we can see that for both load profile, so this on the left is weekday and on the right is weekend. Both uh, they have significant additional load demand, which create new load peak to the existing load profile. Okay, that contain house load only, right? So the existing load profile only contain household load only. And then when we charge the EV, there is a peak at the charging time. Okay, so this one is the result 2. Okay, for object 1. So this one is the PEV charging under TOU price based program for daily electricity price. Okay, so the aim is to get the user pay the lowest bill electricity for daily cases. Okay, so from this, you can see that based on the case, baseline is for weekday, baseline for weekday, TC1 is TC1, TC2, TC3, baseline weekend, TC4, TC5. Okay, so depends on what time the EV user start charging. Okay, so we have the different, okay, different result for each cases. Okay, okay, but the majority of the case uh, is that having the lowest bill electricity is when the user use to charge for TC2, TC3, and TC4 cases charging scenario, okay, which is S1. Okay, S1 block. S1 block, we have 4 blocks. Okay, so the conclusion is S1 blocks have majority for lowest TOU price to be chosen by user. Hence, user can choose TC2, TC3, and TC4 charging time to charge their EV. Okay, rather than they charge during TC1 and TC5. And conclusion number 2, the user can choose to charge their EV at any time if they're willing to pay at any cost. That's another one conclusion. Okay, that one is for uh, daily, and then this one is for monthly. Okay, so the monthly also same as daily. Okay, monthly case is also same as daily cases. Okay, so S1 log also is suitable for most of the charging time. Okay, and also user can choose to charge their EV at any time if they are willing to pay at any cost. Okay, so why I have two analysis for daily and monthly, because price based program can change anytime. Okay, can change anytime, can change based on daily. Okay, because it follow the hours. Okay, time by hours. So in Malaysia currently we pay the bill by monthly. Okay, so this one I want to show you the monthly cases. Okay, the next one, the last one is result number 3. So this one is the PEVE charging effect to the energy consumption. Okay, for result number 1 and number 2, we focus on the cost. For result number 3 is result number 1 is technical. Result number 2 is cost. Result number 3 is back to technical. Okay, but this one is for daily. Okay, daily charging. We can see that the effect of PEV charging. Okay, okay, we want the load profile. Okay, approach the baseline. Okay, means that baseline is there is no peak. Okay, no load peak. Okay, so from this analysis I can conclude that for baseline, if we apply the fixed price and the others price segmentation, TOU price segmentation, S1 is the best price block lah. Okay, and if we charge the car for all cases, S3 is the best with elasticity negative 0.2 is the best price that we can apply to the charging load. Okay, so these are the others for TC2, TC3, TC4, and TC5. Okay, so the conclusion for the result number 3 is the most suitable TOU tariff for household load and the PEV charging load is the S3. Okay, with 8 blocks price segmentation. Okay, with negative 0.27 means that the elasticity in negative 0.27 means that uh, the user is don't care about the price if they charge, so they don't care about the price. Okay, but still they can pay at lowest price. All right. So for status of publication, I have one journal in writing progress, which is this journal will include my objective number 1 result. Okay, status of thesis writing. I have 6 chapter. I plan for my thesis to have 6 chapter. Chapter 1 introduction is 80%. Chapter 2 literature review 60%. Chapter 3 method and analysis for objective 1 is 50%. Chapter 4, 5 and 6 uh, Not I'm not starting yet. Okay. For planning for next semester, I will focus on objective 2 and 3. Okay, which is I'm going to do more on the programming. Okay. Number 2 is continue writing thesis, and number 3 is to publish another one journal. So I think that's all from me. Assalamualaikum and thank you for your attention.